Hi, this video is an overview of the Vitra command line interface. Vitra is a research project for exploring the use of smart contracts without blockchains. It shouldn't be used in production right now. This is really for learning about and exploring the limits of non-blockchain smart contracts. But in this video, I'm going to give a nice overview of how to use the command line so that you can play with it and learn how to use it. So whenever you start Vitra, it will open you into a interactive command line session. This is the main way that you work with Vitra currently. This is actually a Node.js REPL that we're working in, so you can run JavaScript inside of it. But there are a number of commands that we have put into the REPL through the dot commands, and you can list all of them by calling .help. And that's the primary way that you'll want to interact with Vitra. You might use the JavaScript REPL every once in a while, but usually you'll want to use the dot commands. So let's take a look at how to use this. Whenever you first start out, you'll see that if you call .status, you can see what's going on with the interactive REPL, and there is a current working directory for the REPL. By default, there is none, but if you want to work with a Vitra database, you're going to set the directory that the data is stored inside of, and that will establish which database you're working with. So .status currently shows that we have none. I'm going to call the .use command to set the current working directory, and I'm going to have that go to .vitra demo1 under my home directory. So that went ahead and created a directory for us. If I call that status, you'll see that the directory has been set, but there's no active database in that directory, so the first thing we need to do is initialize one. To create a new database, you call the .init command, and then you pass in the smart contract that's going to define that database's behavior. We'll get into the actual contracts later, but for now I'm just going to have it run the counter smart contract example. So I'll call .init and pass in the JavaScript file for the smart contract, and that creates a new database for us. And there you can see that there is a public key that identifies the database on the network, and that it's running inside of this interactive session. Now the database is only inside of this session, so if I were to Command D and close out the REPL, that database will no longer be actively running. I can fix that if I'm so inclined by opening up Vitra again. I'm going to go back to our demo1 directory. The database is running again, and if I want it to persist beyond the use of this command line, I can call .bg. What that will do is close down the database inside the interactive REPL and then spawn another process that will continue to live beyond this session and keep the database active. Now, as you can see, the server was moved to a background process and we reconnected to it. I can call status to see that it's all working correctly, but if I close the REPL, it doesn't close down the database process, so the database continues to execute in the background. I'm going to go back to our database in the REPL, and now let's say that I don't want that background process running anymore. I can return it back into the interactive session by calling .fg, which stops that background process and restarts the database inside this interactive session. This is somewhat useful for if you wanted to set up a database using the interactive session. Once you've done setting it up, you can call .bg, and it will move into a persistent background process that won't demonize. So if you restart your computer, it won't turn on automatically, but it'll continue to persist beyond the interactive session. So that's some basics of managing a database process. Let's look at a couple of useful commands. Again, there's .status for seeing the currently active database. If you want to get more information about the database that's running, you can call .info. And this primarily tells you how many peers are connected to your database and what different operation logs are involved. So we have two logs right now. One operations log, and that's my op log. And then the index, which is where all of the actual state of the current database is stored. There are a couple of useful tools for interacting with these different logs. If I call .history, that will show the history of all changes that have occurred to the current index. And so let's examine this. It's an interesting way to see exactly how all this works. The very first update to that database was a put to the .sys contract source path. and that set the source code of our smart contract. The second modification was a put to the .sys/inputs key space, and that is what set my op log as one of the participants in this smart contract. And then finally, we seal the creation of the smart contract by making a put to the Genesis acknowledgement block there with no value inside of it. That basically tells anybody that is reading the initial blocks that, okay, the database is initialized, no more setup is required, it can now run in its normal operation mode. So you can see under .sys/inputs, we have a public key 1C7511. If I call .info, you can see that is op log 0, that is my operations log. If I want to see the history of not the index, but one of the op logs, I can actually pass in the public key for that op log. At present, you'll see there is nothing there because I haven't published any operations to be executed yet. So that's the .history command, very useful for seeing what's been going on in the history of the database. Another useful command is .ls, excuse me, not .ls, .list, and that shows the current key value entries inside of the current database state. Currently, everything is under .sys, and you can see we have the contract, the inputs, and the ACKs. ACKs are acknowledgements of operations that have been executed. Contract tells us the current source, and inputs lists out the current participants in this database. To understand a little bit more of what I mean by participants or op logs, every Vitra database consists of two different kinds of logs. You have the index log, which is the current state of the data, and then you have the participants or the op logs, and these can be, there could be many different op logs. Right now there's only one, but you could have any number of them, 10, 100, whatever. And lots of different devices can have their own operations logs so that they can participate in the database. And this is how you distribute the ability to make changes to the database. In fact, the design of the entire Vitra system is that every one of the participants will publish new operations on the op logs, and then the executor will pick up on those operations and actually execute them and update the state of the current database in the index. So if we look, it's a little bit difficult to see what's going on with the smart contract given this formatting, but it's possible to see that there are a couple of operations or a couple of functions that are exported by the contract here, a get and an increment. And then we have the code down at the bottom, apply, which actually applies new transactions. And so to demonstrate a little bit more, I'm going to call the increment command so that we begin to set the state of this database. So to actually call an API that is exported by the contract, you do .call, and then you specify which function you want to call. So we'll call increment. And once that is complete, we'll be able to call the list command, and we'll see that the counter was set to 1. And that's pretty straightforward. The increment command emits an operation named increment, and then when it is applied, the smart contract will get the current value of the counter and add 1 to it. If I want to take a look at the history of my op log, we can see that one increment operation was created. And then if I look at the history of the index, we'll see that it acknowledged that operation, and then it reacted by setting the state of the counter. So if I call increment again, the counter is now 2. The history of my op log shows another increment operation, and the history of the index shows another acknowledgement and the put of the counter value to 2. Now let's take a look at a couple more useful commands for interacting with a Vitra database. The methods command lists out all of the methods that are exported by the smart contract. The .source command just dumps out the source code of the contract. This is a slightly easier way to look at it, and again you can see there's a get function and an increment function. and then the transaction handler, which applies the increment operation. And you can see we've used the increment command, but we haven't used the get command, so let's take a look at that, and we'll see it just gets the current value of the counter, and that's 2. So we'll call increment a few more times, we'll call get, and now the value is 5. In addition to .list, if you want to explore more of the current values, you can also call the get command, and you pass in the path, and it will give you the individual value inside the current database. Now, you'll notice whenever I call increment that it emits a transaction ID. Every time you run any kind of mutation on the database, it will be tracked as what we call a transaction. And I can list out all of my past transactions here. You can see that the IDs of these transactions are the name of the function, followed by a shortened part of the participants, the oplog public key, and then a sequence number there. And I can actually take a look at one of these transactions by passing in the ID. And we get some pretty detailed information about what occurred there. You can see that the transaction has been processed. You can see what the call was and its parameters. You can see the operations that were emitted. In this case, there was only one. That was the increment operation. And a proof of inclusion into the op log. So this piece of information tells us, gives us some amount of certainty that the operation that I'm looking at here was actually included in one of the participants' logs. And then you can see the result of handling the actual operation and what kind of mutations that led to, in this case, setting the value of counter. All of these transactions, this information that we're looking at here, is actually being stored inside of the data directory for the database, so I can refer to it later. And part of the reason that we hold on to this information is that you may later on want to verify that the transaction has been run as we were told. And so by calling txverify, you can actually check that inclusion proof and make sure that the participants, the op logs, have stayed honest and haven't removed that operation after publishing it. Okay, now there is 2 other useful commands that I'm going to touch on, and then we'll switch gears. The first one is verify. Verify basically is similar to the transaction verify, except that it is going to verify the full history of the database that we're looking at. And so what verify is doing is actually scanning through this full history of all the changes to the database, and it's making sure that all of those changes match up against the contract, which is published as the source. So verify is really at the heart of what Vitra is designed to do. It is ensuring that the database is correctly being executed by whoever is the executor of the database. If you call verify once like this, you're going to ensure that the execution is correct, but then you're not going to continue to do that. If you wanted to persistently verify it, you could call monitor, and that means that it will continuously monitor the state of the database. You can do this, you can run verification or monitoring whether or not you are a participant in the database. Anybody can do this. Again, that's a really important part of how this works. And if you were to move the process into the background, that monitoring will continue. In fact, monitoring will continue until either the database process is closed or you call monitor end to abort the monitoring process. So monitoring is simply a way to continuously verify all the execution of the contract as new operations occur. To show a little bit about what happens if the contract is violated, I'm going to manually break the contract, and then we can see what happens. So this is where the REPL comes into play here, and we have the RPC, I believe RPC, let me double check that. Yep. We have the RPC object, which gives us some ways of directly interacting with the active database. Normally, you're not going to need this API, but again, it's useful to have. In particular, it's useful for something like calling index dangerous write, which again, you're not going to want to do this because I'm about to violate the contract and invalidate the database in perpetuity. After I do this, this database is done. It will not be able to be used anymore because the contract will be violated. And the way that I'm going to violate it is I'm going to put a value of 100 for the current counter. So let us do that because I do have the authorization and I have made an end run around the sort of infrastructure of Vitra by directly writing to the database. But we didn't want to do that because now when I run verify, it shows correctly that a violation has been detected. As it says, this is a serious issue. It records the details of the error, you might say, though in Vitra I call it a fraud, and it records it under an ID. We can see the details of it here. The executor has violated the contract, indeed we have, and specifically what happened here is that we produced a change to the database which the monitoring process didn't expect. Didn't expect it because there was no operation that should have driven this particular change. All changes to the database should be preceded by an operation. So that's a violation of the contract. Now if I call fraud list, it'll list out the IDs of known frauds. Again, this is saved to disk, so I'd be able to access it at any time. And I can call .fraud and pass in the ID to get all of this information. This information here is what you would want to share with somebody if you found out that there had been a break in the contract. This information here can be shared with somebody to show, yes, this did happen. I have a proof showing exactly the fraudulent entry in the database. And so now we can hold whoever it is that's executing the contract, we can hold them to account for this, most likely by saying, we don't trust you to run the contract anymore and we're going to need to move to somebody else. It is possible, in theory, that a mistake like this could have happened due to a technical error. In fact, I would bet that that was perhaps more likely than intentionally fraudulent behavior. But Vitra is trying to be correct enough that this shouldn't happen because of a technical mistake. Ideally, problems like this should only happen because, well, somebody cheated, and you want to catch them trying to cheat. So we have now put this contract into a bad state. It's no longer usable to us. So we're going to use a new command, and that is destroy. Destroy will remove a database that is in some given directory. And the first time you call it, it'll says, heads up, this is going to delete everything here, including the private keys. Are you sure you want to do this? And if you are, you call destroy again. And there goes our database. It is nuked. Well, now that we've nuked this database, let's go ahead and try something else that's useful. And that's let's get into having more than one participant in a database. So I'm going to initialize in the same directory a new database. This time I'm going to use the key value store contract. And if we look at the source code of this one, it's a little bit more complex. It includes these commands here. The first set of commands are some pretty simple key value commands for getting a value, listing values, putting and deleting values. So the basis of this contract is to be a simple key value store. But it also includes some tools for setting an administrator in the database. That is one of the participants in the database that gets to control the database with more permissions. And then two commands for adding and removing participants, which only the admin is allowed to do. And the transaction handler enacts these commands. So if I call info now, you can see we have a fresh database. If I call history, you can see we set the contract. We added a op log, which is myself, and then we sealed the contract with the Genesis acknowledgement. So the first thing I'm going to do is call getAdmin, and we'll see that there's currently not one. And so we want to have an admin here, and I'm going to set it to myself. The idea of an admin is really specific to this contract. You can see we have get and set admin, and add participant, and remove participant. Again, this is all specific to this contract. So we're going to call setAdmin, and you'll see that there are parameters to these methods in this case. That would be the pub key parameter. So I'm going to do a command line sort of syntax of -- pub key and pass in my oplogs pub key. Now if I call getAdmin, we'll see that's now set to me. Now what we're aiming to do here is set up this key value database so that it has more than one participant. Yeah, that's what the add participant and remove participant methods are for. So to do that, we're going to want to open up another instance of this database. The first thing I'm going to do is I'm going to open up another Vitra session, and I'm going to use a different directory this time. This time I'm going to use demo2. Previously, whenever we wanted to set up a database inside of a directory we called init, and init would create a new database there. In this case, we don't want to create a new database, we want to load an existing one. And so we're going to take the public key of this database that we've been working with previously, and rather than call init, we're going to call .load and pass in the public key. In this case, this will cause it to jump onto the network and sync down the information about the current database. And so now we are looking at it, and notably, in my initial session, the one that created the database, you can see that I am the owner of the logs that are involved in this database. But in our loaded version, I'm not the owner of either. So now we're looking at it as a kind of a read-only viewer rather than as an owner of the database. But what we want to do is use the add participant commands to get this second session to become a participant in this database. If I called something like put key foo and value bar, it's going to fail. It's because I'm not a participant. So the first thing that we need to do is create an op log for my new session over here so that I can be added as a participant to this database. And to do that, we call mk oplog. So this has created a wholly new log that I have control over, but that alone isn't enough to make me a participant. All that means is that I've created a log, and if I call .info, you can see that it's actually listed under the detached op logs, meaning that it is not attached to the database, it's not actually a participant. We actually need something else to happen for me to become a participant in this contract. And so what we're going to do is we're going to call the add participant command that was defined by the contract. And we're going to pass in the public key of the op log we just created. Is it add participant? Let me remember what my method is called. That's a misspelling. Okay, so now we've called add participant, and the logic of the smart contract is such that when you call add participant, eventually it will spawn the add participant operation, and that will eventually call add oplog with the public key that we passed. As a consequence, if I now call info, you can see that it's no longer detached. It's actually been added to the participants inside of this database. So now whenever I decide to call the put command, I'm actually allowed to. And if I get at key foo, you can see that the value got written. It's called put again and get again, and you can see that I'm able to update it. So now I am actually a participant in this database, as indicated by the fact that it is no longer a detached oplog, it is a member oplog. So there's something sort of interesting about what we saw there, which is that creating an oplog with the .mk oplog command, that's actually standard functionality for Vitra. But actually adding a participant to the oplog, there's nothing standard for that. In this case, adding and removing participants is entirely defined by the smart contract that a given database is using. There are no standard methods for doing that. So if a contract was designed without any methods for adding and removing participants, you wouldn't be able to do it. The reason that a smart contract has to define that functionality is entirely because you want to have the ability for complex business logic around who can participate in a database. Maybe you want to have a vote involved before somebody gets added or removed. So we don't have any standard methods in Vitra for controlling who participates. It has to be programmed specifically by the contract to choose who is involved. In this particular case, this is entirely set by who's the admin. If I tried to, well, let's take a look at who the admin is currently. So it's the pub key of D278C, and you can see over here that I am not the owner in this session of that oplog. That's this session over here. As a consequence of that, if I tried to do something like override the current admin, setting it to myself, the transaction will complete, But when it actually tries to execute itself, I can see the results whenever I call it .tx. You can see that actually didn't successfully execute. The result of that transaction was that it was an error. You need to be the admin to set the admin. Likewise, I wouldn't be able to set the current participants, and that's because if we look at the source code, whenever you call set admin, add participant, or remove participant, we fetch the current admin entry and make sure that whoever it is that's making this transaction actually is the current admin, and if they're not allowed to do it. So this is how the smart contract is able to introduce some more sophisticated business logic around its own management. There's only one more command that I want to share before we stop here, and that would be the command for destroying an op log. You probably won't need to do this very often, but you never know. It's good to cover it in our documentation here. So for step one, I'm going to remove that participant using the smart contract. And now when I call info again, you'll see that participant has been removed. The session that owns that op log, now it is detached again, no longer active. And if I didn't want to have to hold on to that op log anymore, I could call del op log and pass in the public key, and now it's been dropped from my listing of detached op logs. So that is an overview of the Vitra command line usage. Hopefully this gives you a good idea of how to get working with Vitra and making your own databases, trying out some smart contracts and things like that.